Okay, all right. So today we are beginning a brand new unit, which is Unit 4, okay, which talks about linear functions. So remember back in Unit 3, when we talked about functions, we remember that there are various types of functions, right? And so one of the most basic functions is a linear function. So we're going to begin the unit on that. And the first lesson on linear functions is slope. Okay, so let's talk about that. All right, let's go. Okay, all right. So just looking at this slide here, it says slope, a quick review. It's not a review at all, actually. This is something that you probably have never done, okay? Unless you did it with a tutor or, prepping for the SHSAT, okay? So, all right, let's talk about what a slope is. So here I have three examples here. Now, don't get thrown off by like all this stuff here, okay? Don't get thrown off by all this language here. I had to find the best picture, and so don't pay any attention to like cosine and theta and all that stuff, all that Greek letters and stuff. Okay, I'm just gonna like make a very simple example. So let's say you go behind our school, right, to the playground, right, and you see a skateboard ramp, right. Now ours doesn't look like this, right? The skateboard ramp, right? And you see people skateboarding on it, right? Right? The ramp determines, the ramp a lot of times determines how difficult the skateboarder is attempting to do a trick, right? So if you ever watch, I don't even know if they do that anymore. So ESPN used to have this thing called the X Games, right? Where they have people like do extreme sports, and one of the events was skateboarding, right? So and they have these very like steep skateboard ramps, right? And people do all sorts of tricks on it. I don't know any of the names, all right, because I don't skateboard, right? Now imagine, right? We make this skateboard ramp steeper and steeper. Now, think about it. What does steep mean then to you? Right? Meaning that one end of the skateboard ramp, right, is lifted higher and higher, right? So to the point where if you look at this example here, right, that you would probably say, right, that this ramp, I don't know why I can't draw straight lines today. All right, well, it's a Monday, so maybe that explains it. All right, this is steeper. This ramp is steeper, hence the two arrows, is steeper than this ramp, which is steeper than this little ramp here, right? And so that's the definition, the informal definition of slope. Slope measures steepness. And that's slope in a nutshell. Okay? All right, now, let's move on then. So another way that we could measure slope, right? And I'm going to use a non-physical description, right? Because the first one was a skateboard ramp, right? Imagine, right? If you're going at a very high speed, and we're going to talk about this again later, right? Imagine, right, you're traveling at a very high speed. So compare yourself riding a bike versus comparing yourself when you are on the airplane, right? The steeper the slope, let me see if I could draw a blue line here. That's actually straight. Let's see. Do I have a blue line here? Okay, good. Right? So imagine, okay, wrong thickness. All right, let's see. Imagine, right, that you are riding a bike, right? And that's how steep it is. Why? Because look, it takes you 4 hours to cover a very short distance, right? Whereas if you take, let me use a different color, okay? Whereas if you, let's say that's you on a running, right? Let's say you're on a bike, right? In the same amount of time, now you travel further, right? Let's say you use a different kind of transportation, right? And let's say this is you in a car, right? Now you're going faster and faster, right? To the point where you're going fastest when you're at this line and you're taking an airplane, right? Where in 4 hours, that's how far you can travel, okay? Right? So another way to conceptualize slope is by speed, right? Because it's a function, right? Remember that, right? What's the function comparing in this case? Time versus distance, right? So the faster you go, what it really means, right? The higher the speed is, and that really means speed really means then how much distance you travel as a function of time, right? So that's another way to conceptualize slope. So in other words, slope isn't just a physical manifestation of an object. It can be just any measurement of two different units. Now that we said that, right, two different units, that sounds a little bit like something you learned in the 6th grade, which was unit rate. Okay, so this is why I wrote this. In many ways, right, slope is synonymous with unit rate. So if you look at the unit rate, right, it's always y over x. So for example, the language of unit rate sounds something like, $3 per chocolate bar, right? Something like 15 miles per hour, right? So that's a unit rate, and unit rate essentially is the same thing as slope. Okay, so let's recap what I've talked about so far, right? What is slope? Slope measures how steep something is. Now, from a physical standpoint, we can use a skateboard ramp, right? Or even a treadmill. You ever seen people work out in the gym on a treadmill? All right, I've never seen anyone do that in person because I've never stepped foot in a gym before. But, right, if you see someone on a treadmill, right, and they're like panting, right, and they're sweating, right, a lot, right, you can imagine that the treadmill looks something like this, right? It's very steep, right? So that's one way to visualize slope. The other way to visualize slope is on a graph where the steeper the line, right? The steeper the line, the more the line becomes vertical rather than horizontal, right? The more a line becomes vertical, the steeper it is, right? And the higher the slope, okay? So a flat line, almost flat line, has a very low slope, right? Whereas a line that's almost vertical has very, very high slope, okay? Now, let's move on then, right? Slope has a formula, and you absolutely have to write this down. This is a non-negotiable. You have to write this down, okay? So take a moment, press pause, and I will explain to you what this formula is once you copy it. So press pause right now. Okay, all right, and we're back. So this is the slope formula. Okay, so what does the slope formula say right now? Notice, right, how this is y over x. Slope, first of all, slope is represented by the letter m, lowercase m. Okay, all right, so what I've decided to do is give you a numeric example. Okay, so here's what we're gonna do. So here, what I'm gonna do is I'm going to mark off the 2 points here and then ask you to find the slope, but show you in a way that for someone who's learning this for the first time would understand. So here I got 2 points here, right? This is 0, 1. Now, this is our first point. So technically speaking, this is our first x value and our first y value, right? That's all it is. I'm just using numbers to represent letters that were in the formula here, right? Now, our second point is, let's see, what is this? 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So this point right here would represent our second x value and our second y value. Okay? Nothing crazier. Now, as I've told you before, a slope just measures the rise over the run, because anytime you do that, it will give you the most accurate representation of just how steep this line is, just how steep this skateboard ramp is, right? Now, I could do this, I could count, right? So if I were to ask you, hey, how long is the rise here, right? So how long did this go up? All you would have to do is technically just count, right? So you would just count 1, 2, 3, 4, 5, 6, 7, 8, right? So once you count that, you will realize that's 8. Now, the run, what is the run? It just means the horizontal, right? So rise means vertical, run means horizontal. So the question sounds something like, well, how far do we go from this point to this point? So imagine this is like a right triangle that we have to complete, right? So again, the rise, right? From this point to this point, how far did it go up? It went 8 units up, right? And what was the run? Let's see, right? Meaning this part. Let's see, 1, 2, 3, 4, 5, 6, 7. So I count 7 boxes. So the run here is 7 boxes. So what's the slope? The slope is 8 over 7, right? Now, you guys are a very sophisticated group of people. You don't want to count this every time you do this, because what happens if I were to just give you this question, right? So if I were to say, find the slope of 0, 1 and 7, 9, you wouldn't have to set up an XY axis, right? Find a piece of graph paper, draw the line, connect them, draw the triangle, count the rise, count the run. Like that would take you 5 minutes, right? So that's what the formula is for. The formula says, right, for slope is y2 minus y1. By the way, this you would have to memorize. Okay, I'm just telling you this now, right? y2 minus y1 over x2 over x1. By the way, there's another way to say that. This means delta y. So delta is a Greek letter that we use to represent change. So how much did the y change? Over delta x. How much did the x value change? Well, let's find out, right? So this was, let me color code this again. So this was the first x value, and this was the first y value. And this was the second x value, and this was the second y value, right? So if you take, right, the second y value, y2 minus y1, right, and then you take x2, right, the second x value, minus the first x value, x1. Look, 9 minus 1 is 8, 7 minus 0, 7. Same answer, right? Nothing changed. And that's the slope formula. What the slope formula does is that it allows you to find the slope without having to draw it. Okay? Now, in the event that the line is drawn for you, if you want to count rise over run, be my guest. Okay? But in the absence of a line that's drawn for you already, use the formula. Okay? So, and by the way, the ability to use this formula has implications down the line. So this is why I'm asking you to memorize that, okay? And throughout practice, you are going to memorize it. Now, how am I doing on time? All right, you know what? Let's do one practice question. That's it. Just one practice question, and then that'll be it for today, okay? And tomorrow, we're going to finish this topic off, okay? So here, try this one. Find the slope of -3, 4, and 3, 3, 9. Okay, fine. All right, so if you want, follow the formula, right? Okay, I already follow this example here. Okay, and then press pause right now. Okay, all right, and we're back. So the answer is 5, 6. Okay, we follow the formula. Now, also, I want to point this out to you. If you go the other way, so you notice, right? It's always y2 minus y1, x2 minus x1. So x2 minus x1, right? So we're kind of going in that left direction. If you want to go the other way, you can actually. So watch this. Right? So if you want y1 minus y2, so in other words, if you want 4 minus 9, and then -3 minus 3, watch. That's -5, and that's -6, which is 5, 6. Same answer, right? It's perfectly okay to do that. Now, what is absolutely not allowable is this. I'm going to use red. You cannot go one way and then come back the other way, meaning this. Let me show you. You can't go 4 minus 9, right? Left to right, and then you do 3 minus -3. Why? Look, that's -5 over 6. That's wrong. We don't have a negative in the slope there. So that is actually wrong, like factually wrong. You cannot, I can't emphasize it enough, you cannot do this, okay? This you can do, and this you can do. Okay, so that wraps up the lesson for today, okay? All right, hopefully the explanation was good enough, and okay, all right, I'll talk to you guys tomorrow. Bye-bye.
OMG, that was so good.